section 2.7 for function decomposition. So today is the fourth function decomposition. This is in section 2.6 before the inverse functions. Why is this important? It's basically important for those of you who from here will have to take Math 230. So let's look at the following function. Let's say we have f of x equals the square root of x squared minus 3. We're asked to decompose this function into an inner function and an outer function. When I talk about inner and outer, I mean which function I apply to x first and which function I apply later to the result of f of x, of that first function. So this is not a difficult situation if you would pay attention for a second. This only says what? It says if I want to evaluate this function, I will evaluate, let's say, for 3. So I perform this operation first. And when I'm done and I get a number, then I apply this operation to that number. So this must be the inner function. There is more than one correct answer. And then to this number, which let's say becomes 25, then I take the square root. So that's the square root of x. So the inner function is the function that I perform first when I evaluate. And the second function is the function applied after the result of the first one, or the outcome of the first one is obtained. Okay, let's look at another, and I would like you to decompose this function into 2 functions. Of course, I can use 3 functions, but we only need 2. Okay, so let's say h of x is 1 divided by x squared plus 5x minus 3. And the same question here, we're asked for the inner and the outer. But of course, when I call these, so if I name this, let's say g of x, and I name this h of x, then I have to show, or it's very clear that f of x will be h of g of x. Because that's the inner, and I have to apply it first. And that's the outer, and I apply it second. So can anyone give us a potential answer here? Again, there is more than one correct answer. Inner. I can never do 1 over x. If you ask me to evaluate for 5, I can never do 1 over x first. That's not going to work, right? What do I have to perform first? If I ask you evaluate this for x equals 5, what will you perform first?
X squared plus 5x.
Absolutely. X squared plus 5x minus 3. After I'm completely done and I get, let's say, 25 or 30 or 15 or negative 5, then I will apply the function 1 over x. Is that better? I apply this function first. I get any number you want, not 0 though, and then I perform the operation 1 over that number. Okay, I think we should try another. So let's say g of x equals the absolute value of 15x minus 2. Inner and outer. So absolutely, the inner function is 15x minus 2. And when I'm done with that, and let's say I get whatever number, that's why I cover it. It's just a number now. Which function I apply to this number? That's it. Why is this important? This is important for brief calculus, math 230. Less important for us moving forward, but still an important topic. Okay. So this was done because for some reason, I omitted that question. Back to 2.7, the only item that is left is how to find the inverse function. How to find the inverse of a function. I'm missing something and I need help. What am I missing here? Of course. If it's not one-to-one, thank you. If it's not one-to-one, there's no discussion about its inverse. There's nothing to say. If the function is not one-to-one, we have nothing to say because it doesn't have an inverse. Excellent. So can you give me an example of a function that we graphed several times this semester and we know for sure that it's one-to-one? A very simple one. What function would you pick? Especially if we said the simple one. What can it be? Of course. Can anyone give us a linear function? Any linear function. What about 3x minus 6? Is that okay? Yes? Is this a linear function? Is it one-to-one? Is it one-to-one?
Yes.
Of course. It is one-to-one. All linear functions are one-to-one. Does it have an inverse function? Yes. Okay. It's a 4-step procedure. 4 steps or 4-step procedure. Step number 1, replace f of x by y. Before I do that, I would like you to tell me whether you give me permission to do that or not. Am I allowed to replace f of x by y? Yes, no, maybe?
I'm going to guess and say yes.
They are the same, of course. So then I have y equals 3x minus, y equals 3x minus 6, of course. In step number 2, sorry about that. In step number 2, I will perform a procedure, but I need your permission first. Step number 2 is interchange x and y. Meaning, I see y, I put x. I see x, I put y. But the question is, am I allowed to do this? And before you say yes or no, allow me to show you our discussion from last time. We said that the function, and we gave an example 1 and 2. So function, whatever function is applied to 1, and the result is 2. But the inverse function will be applied to 2, and the result will be 1. So this is the y value for f, but this is the x value for f inverse. So I apply f to x equals 1, and I get y equals 2. But now this number 2 becomes the x value, or x, it's part of the domain of the inverse function. So now I apply the inverse function to this x, which happens to be 2. That's the reason why one time, just this time, I'm allowed to swap x and y. So we did that, and we explained why. Number 3, we're solving for y. Why? Because this is what we're after. We want to determine the inverse function. How do I solve y equals 3x minus 6 for y? course, I add 6 and I divide by 3. So then x, I'm sorry, I copied it incorrectly. I'm telling you, this is so hard for me in here now. Sorry, I was supposed to copy x equals 3, y minus 6, and I copied from there. So we add 6 and we divide by 3. Sorry about that. So then y equals x plus 6 divided by 3. Do not attempt to simplify anything. And in final step, we have f inverse. This is what I have to replace y by. And this is x plus 6 over 3. And let's also suppose that we are asked to graph these two on the same coordinate system. Last time I did not write that note. We ran out of time, so let's write the note now. Note: the graphs of f and f inverse are with respect to the line y equals x. The graphs of f and f inverse are always blah, 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 with respect to the line y equals x.
Symmetric.
Thank you very much. Sorry. They are always symmetric with respect to the line y equals x. Okay, so please remember, because I went to the next page, I'm going to copy f of x, which is 3x minus 6, and I'm going to copy here f inverse, which is x plus 6 divided by 3. And now we're asked to graph both. That's our next step on the same coordinate system. And I would like to start with the first one. So I have f of x equals 3. I'm not sure. So 3x minus 6. We need two ordered pairs, obviously, because it's a linear function. So we always look for the x-intercept and the y-intercept. So when x is 0, how much is y? Thank you. So it's 0, negative 6. Please write the ordered pair before you move on to the next one. And now let's say this is 0, y is 0. 0 equals 3x minus 6. I move negative 6, so I get 6 equals 3x. So x equals. It's okay, we are dividing. Yeah, you're right. So 2 comma 0. So now I'm going to plot these two ordered pairs. Is everyone in agreement with those two ordered pairs? When x is 0, I determine y. When y is 0, I determine x. Yes? Perfect. These are the x and y intercepts. So now I'm going to plot 2 comma 0. And I'm going to plot 0 comma negative 6. I will connect and extend. So remember, please, write f of x equals 3x minus 6. We also know that every time we graph the function and its inverse on the same coordinate system, we must graph y equals x. That's why we wrote this note. The graphs of f and f inverse are symmetric with respect to the line y equals x. It has to be part of the graph. As you see, it's not a solid line, but it has two purposes at least. One purpose is to make sure that whatever I graph is symmetric on the other side. Number two, I have to make sure that where the function crosses y equals x, the inverse must cross as well. Okay, so now I should do the same, perform the same steps for f inverse. I refuse to do that. And I will ask you to give me two ordered pairs that I should plot in order to graph the f inverse.
Negative 6, 0.
Of course, all we have to do is just reverse. Perfect. So we do have negative 6, 0. Excellent. because it has to be this point, the mirror image of this point. And now the other one is the mirror image here, but I really don't need it because I already have two. So this is the graph of f inverse, which is x plus 6 divided by 3. And for these two functions, what do you think f comp f inverse will equal to? Thank you. Why would the function composition in either direction will equal x? Why? Because the functions are in inverses of each other. We determined this. We were given the function, we determined this. So obviously they must be inverses of each other. If I apply this and then this, or vice versa, I must get plain x. Questions, please. I already sent a note test to the testing center, but hopefully we can finish chapter 2 today. But we also have 3.1, 3.2, 3.3, 3.5, and 3.6. So this will have no difficulties. This should not, although I'm reviewing the whole thing, and this should not. However, these 3.2, graphing polynomial functions, and 3.5, graphing rational functions, require attention. Not going to happen in 20 minutes. Okay, so our final section, which I claim does not have much to do with the rest of the chapter, deals with a distance formula, midpoint, and the equation of the circle. Okay, so let's picture 2 points, and let's try to determine the distance between those two. So let's say I have point A, and let's say I have point B, and I want to determine the distance between A and B. I'm going to create, because I can't plot point A without having coordinates, so I'm going to say x1, y1 are coordinates of the first point, and x2, y2 are the coordinates of the second point. Well, obviously, this must be x1, this must be y1, this must be x2, and this must be y2. Next, I'm going to form a right triangle. And there is a theorem that will allow us to connect the sides, the length of the sides of the triangle, the hypotenuse and the legs in one equation. And that is what theorem? And every time I say Pythagorean Theorem, my students say, oh, I know c squared equals a squared plus b squared. That means nothing. You have to say the longest side squared equals the sum of the squares of the legs. Because I don't know which one is a, which one is b, which one is c. If you just say a squared equals b squared plus c squared, doesn't mean anything. So the idea is the longest side, which is the hypotenuse, squared, equals this leg squared plus this leg squared. But you can say, wait a minute, you don't have the legs. You don't have the measurements. Okay, so let's find the measurements. Can anyone tell us how much is this? And can anyone tell us how much is this? If this is x2 and this is x1, what could this be?
X2 minus X1.
Perfect, thank you. If this is y2 and this is y1, what could this be?
Y2 minus Y1.
That's it. And now we can use the Pythagorean theorem in this triangle. Can anyone dictate? And let's start with the hypotenuse. The hypotenuse squared equals, and it's a sum of two squares. Perfect. x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula, but we like to take the square root from both sides. When we take the square root from both sides, I always said don't forget to put what on the other side. Right. In this case, it's a distance. I cannot put plus or minus. It can only be positive. And this is the distance formula. We also have something that is called the midpoint. And the midpoint is the point that divides the entire segment into two equal parts. We say it bisects. Okay, so here it is. This is point M. This piece has the same measurement with that piece. So AM and MB are equal. So what are the coordinates of, and in the same way we can show and prove what are the coordinates of the point M. All we have to write is the average of x values, comma, the average of y values. What y values? These x values and these y values. So I have two x values, x1 and x2. What will be the average of those two? And that will be the x coordinate of the midpoint. What is the average of two numbers? What does it equal to?
Divided by 2, so X2 minus X1.
It's the sum. It has to be the sum.
Plus 2 divided by 2.
Excellent. That's it. y1 plus y2 divided by 2. So we're going to look at examples in a minute, but this is all we needed to know about the distance formula and the midpoint. So if anyone would kindly give us two ordered pairs, any two ordered pairs you can think of. But just have some negatives in there, not all of them, but some negatives so we can see how to handle that. Negative 2, comma 4.
3, -7.
And 3, -7. Excellent. So we're given 2 points, negative 2, comma 4, and 3, comma -7, and we're asked to determine the midpoint and the distance. I shouldn't write equal. I don't want equal in there. And the distance. But let's start with the midpoint because it's the easiest. It only takes a blink. So please add up the x values, x coordinates.
So -2 plus 3 is 1.
Perfect. So it's 1/2. Please add up the two y values, y coordinates.
3. Oh, -3.
Very good. Done. So now we want to determine the distance. I recommend write the formula. Remember, you do not try to simplify this. You cannot simplify a sum. If the radicand is a sum of terms, you cannot split the radical. So don't attempt anything here. This is it. This is the distance formula. Write the distance formula one more time, right here. And I recommend writing underneath the corresponding coordinates. It's okay if you write x1, y1, so you don't make an error. That's fine. x1, y1, comma, x2, y2. And now carefully plug them in. But I'm going to write them underneath first. So I have 3 minus, so this is 3 and this is -2. This is -7 and this is +4. I want to avoid nested parentheses because that's where problems occur. So let's do this together. 3 minus negative 2. How much is that?
5,
How much is 5 squared?
25.
That's it. Excellent. How much is negative 7 minus 4? Negative 11. How much is negative 11 squared?
22.
It cannot be. If it's squared, it's not possible. It's a distance. It's the length of the leg. Good. So then the distance is the square root of 146. If you try to take simplify this, if I divide by 2, I get 73. There is nothing I can do. This is it. This is the exact. If you're asked to approximate, then you put in the calculator and you approximate. So if I put the square root of 146 in the calculator, I get 12.08. Let me show you. Sure. So right here, second, the square root is right here with the second key, and we have 146, 12.08. Very good. Final step here in chapter 3. Any questions about any of this? Midpoint, distance formula, anything? Anything? Okay, so now let's talk about the equation of a circle. Bear with me and say that this is a circle. I know it's not. It has a center. By convention, the center has a notation h comma k. This is its x coordinate and this is its y coordinate, of course. So this is the center. I hope you agree that this distance from the center to any point on the circumference, this distance or this one, it doesn't matter. They're all equal to, very good, anywhere on the circumference of the circle, I'm going to denote the point A with coordinates x comma y. I'm going to put also here h comma k. And I have a question for you. What do you think is the relationship between the distance AC and the radius? Is one bigger than the other? Absolutely the same. Great job. The distance between any point on the circumference and its center, the center of the circle, must be the radius. Must be equal to that. Perfect. Excellent. Good. My next step is I will keep R on the right-hand side, and I would like you to give me the formula that we just discussed for the distance AC. And tell me how to write it. Go ahead, try it. It's up to you. Anyone? Yes. So you have to say the square root. Yes, I'm ready.
X minus h squared plus y minus k squared.
That's it. This is the equation of a circle. This is the equation of a circle. However, we don't really use this form. But what form? Let's square both sides and tell me what you get if you square the left-hand side. What do we get? And what do we get when we square the right-hand side? When I square the right, what do I get? That's the easiest one. Very good. And when I square the left-hand side, it's still easy. What do I get?
X minus h plus y.
Thank you very much, Haley. Wonderful. That's it. This is what we prefer. They are both the same. Okay, there are three different types of problems here. Three types of problems. Here's number one. Given, give me a center, any center you want, and give me a radius. Find the equation of the circle. Give me a center, anywhere you want the circle to have the center. Not too big, so we can also graph it. I want to graph it. If you say 16 comma negative 15, it's going to be difficult for me to plot that. Okay, let's say negative 2 comma 3. Smaller, so we can, yeah. And the radius, how big do you want the radius to be?
5.
5 it is. Perfect. Please give me the equation of this circle. Centered at negative 2 comma 3 with a radius of 5. How will I write the equation? Say it again.
X plus 2.
Very good.
Plus 3 squared equals 5 squared.
That's it. This is the equation of the circle, centered at negative 2 comma 3, and with a radius of 25. Do we have any doubts, any questions on this? Is this okay? Now let's graph it, because we may be asked to graph the circle. We have to graph the center. We have to plot the center first. So let's do that. That's why I didn't want to be too far out. It doesn't matter really. So here it is. And now here's what I'm going to do. I have the center of the circle. I know the radius is 5. I will plot a point 5 units away west, 5 units away north, 5 units away south, 5 units away east, and then connect. So 5 units. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. It's not going to be perfect, far from. And this is the circle with this equation. Now I'm going to ask you, please find the domain of this circle.
So one quick question.
And the radius, and the ranges. Yes, please.
So you plot your points first, and then there are 5 from each point. Is that what you meant?
No. No.
I'm lost.
Okay. You first have to plot the center. All points have to be 5 units away from the center.
So
what's-
So we may you create a point west, a point north, a point south, and a point east, 5 units away, and then you connect those points.
the center is given a constant period. So it's negative
The 2, and okay, that's what I needed. I'm here. Focus.
Good. So can anyone give us the domain of this circle? I know it's not a function, but it still has a domain, and it still has a range. And let me make it easy on you. Negative 2 comma 3.
Negative 2.
How far to the left does it go?
5 units.
Very good. But I already have negative 2. So then how far? Negative 7. Very good. How far does it go to the right?
3.
Yes. How far does it go below?
2.
Yes, but negative. Yes, very good. Awesome. And how high does it go up?
8.
Excellent. So although it's not a function by the vertical line test, we can still determine its domain and range. Do we understand what happened? Yes, everyone? Okay, this is one type of problem. Here's the second type. Given x minus 3 squared plus y plus 4 squared equals 49, find the center and the radius.
The radius is 7.
Yes, I agree perfectly. Excellent, thank you very much. And here's type number 3. However, for this one, I have to select problems. On the spur of the moment, I cannot create a problem. So, of course, if you have your book or you have your laptop, if you want to open on page 332. And you can select anything from 53 to 64. However, if you select a difficult situation, I would like to intervene and select a different one, and then we'll do your, we'll definitely work on the problem you pick, any problem. $57. It's a good one, thank you. Perfect. In 57, we have x squared plus y squared plus 8x minus 2y, and minus 8 equals 0. It's a perfect pick. Good. And here the question is asking us to show whether this is the equation of a circle. So that's the question. Does this represent a circle? Does this equation, see, represent a circle? And my answer to this question is no clue. I have no idea. If somehow I manage to present it like this, then yes. If I cannot present it like this, then it's no. But at this point in time, I have no clue. Maybe. So let's look carefully at this. Can anyone suggest anything from our past? Because I see what this is all about.
H and K is vertex, there, one vertex on the
No, there is a circle doesn't have a vertex. Very good point, Ben. Let me just, Steve, don't forget what I just want to say one thing. So Ben is absolutely correct. Because when we look at quadratic functions, and this is 3.1, we have basically the same notation. And that is confusing. So the H in here and the K, indeed, he's right. They come from the vertex. But not to be confused with what we're doing now. Why are we using the same notation, H and K? Beats me. I don't know. I don't know, but this is the convention, right? And many books use the same notation. So not to be confused with this, we're talking about a circle. But yes, so please keep that in mind. We're going to get to chapter 3 hopefully after this. So these are the same letters, but these mean something else in this scenario. But here it's a different story. Thank you, Ben. Excellent. Yes, please, Steve, I'm sorry, forgive me.
So I would think I would start by making it a comparable format. So I would put 8 on the opposite side of the equation symbol.
Okay, you want to start with that? That's fine. Good. Then?
Then would you be able to group the x squared with the plus 8x?
Excellent. As long as I add something that they're missing to both sides. Excellent. What is this procedure called? Remember when we looked at something in the past, I said this is not for this. It's for this. What did I say? What was it? No cell phones, please put that away. Oh, Please put that away. In your backpack, anywhere else. I don't want to see it on the table. Thank you. So, what do we do? What procedure is that? I know I tortured you with it, and I also said I don't like it because it's not for this. Yes, completing the square. Exactly. This is why I tortured you with this. For this, we have to complete 2 squares. One, as Steve said, with x, and the other one with y. Okay, excellent. That's why we studied completing the square. Because I mentioned that many times. I'm sure you're sick and tired of me saying that. Completing the square cannot solve a quadratic equation, right? You complete the square, now what? You have to apply the square root, which is a different method. So then why bother? Well, we studied it because it's potentially applicable if you want. It's half the way, but especially for this. Okay, so remember the middle coefficient is? Yes, so 8 divided by 2 is 4, and we square and we get 16. So this is the number that we have to add to both sides that will take care of these 3. So what is it? These 3 are here. What? Right. Exactly. Because x plus 4 squared is x squared plus 8x plus 16. Good. Now we're focusing on y. Y squared negative 2y. Yes, which is? What do we add to both sides?
Minus.
I can't. I can never have a -1 because that will not be a perfect square. Right? The third term is always positive no matter what because I have to square it.
So, yeah.
Indeed. So now these are here. 1, 2, 3. 1, 2, 3. Yes? If this is minus. Yes, -1. Good. So now I have 8, 1, and 16. These form the right-hand side. So what do we get? 25. Only now I can say yes, yes, indeed. The given equation is a circle, represents a circle. And now I'm also able to identify the center of the circle and the radius. I'm ready. Excellent. Excellent. Yes, you do. Of course you do.
Sorry.
Of course you do. Any questions on this?